Hello, my name is Ryan Hayashi. I am one of the authors for a simulation versus an immersive virtual reality approach on student learning outcomes. Thank you very much for stopping by and watching this presentation. So let's get straight into it. So, a quick overview. We're going to go over the introduction, our research questions, the methodology, the theoretical frameworks that dictated that methodology, and then the results, and then the conclusion. So, a quick presentation. So, we all know there are a wide variety of tools instructors use to teach key chemical concepts such as nomenclature, so naming ionic compounds, acids, bases, and salts, atomic structure, and balancing chemical reactions. A lot of these tools have a lot of different values to them. Study guides have been around for, probably as long as most people can remember. Um, and they offer a lot of freedom in what students do. They could take home the study guide, they can practice at their own pace, and, it can do a lot of things to really benefit students' learning. Another common one that a lot of people have used for a very long time are PhET simulations. So those little simulations on the computer that could show a chemical reaction, maybe how you balance something out. And these have all been around for a very long time to really enhance the way that we teach these key chemical concepts. Because a lot of these concepts, nomenclature, atomic structure, and balancing chemical reactions, are something that a lot of students struggle with, especially in general chemistry for non-STEM majors, that being Chem 3A that we all know and love at Fresno State. So we're always looking for new ways that we can improve the way that we display these topics for our students to give them the best education they possibly can in their short time with Chem 3A. A lot of these, especially the simulations and study guides, have been around for a really long time. And they require a lot of thoughtful instructional design on our behalf. PhET simulations, you have to think about what PhET simulation you're going to use. Are you going to make a worksheet or study guide to go along with it? How are you going to pace the students throughout? How are you going to walk around the whole time, making sure everybody's staying on topic? And since PhET has been around for a really long time, there's a lot of resources and integration that has been done with PhET simulations, and they've been tried and true for teaching these key chemical concepts. But as chemistry educators, we always have to look at new ways that we could potentially enhance our students' learnings. And one of those ways that we are investigating currently is immersive virtual reality. So what virtual reality is, it's simply a headset that goes over your face and it immerses you inside of a digital simulation. And basically, what this allows us to do is to display these key chemical concepts in a way that students will most likely not have access to in many other ways. PhET simulations provide a 2D experience, flat on a computer screen, while immersive virtual reality may allow students to pick up molecules, rotate them around, to really see how things are moving in chemistry, how ionic compounds come together to form these lattice structures, how many atoms, may be in each side of a chemical equation balancing. Um, but with this comes a lot of questions on how is it worth switching, pulling up all of this work that has been done on simulations and study guides and other instructional tools to make way for a brand new technology that may or may not prove to be as effective as these older methods. So that is what we have done. We have performed an investigation on Chem 3A to figure out if it is worth using immersive virtual reality to teach general chemistry or if it's worth sticking with study guides and PhET simulations. research questions are nomenclature, that being ion pounds, or react. This will allow us to get direct impact on students' performance from one side to the other, or does it provide no statistical significance between the two? The second research question is for our qualitative analysis, that being what are students' and instructors' perspectives on a simulation versus a virtual reality approach. The qualitative allows us to look at the way that students and instructors see these technologies. Maybe there is no statistical significance between them, but students much more enjoy using the virtual reality and they have fun and they look forward to it. That could lean maybe towards attempting to integrate immersive virtual reality. Or maybe on the other end, there is no statistical significance. And let's say instructors are heavily resistant to wanting to integrate this new technology that could lean against immersive virtual reality. So it allows us to look at this from multiple ways to really see what is best for our students here at Fresno State and, other colleges as well. So for our methodology, so as you can see here, I do not have the quantitative listed currently. That is because the quantitative data is still being fully finished and will be available in a couple of weeks for me to share with everybody. But a quick rundown of that. The quantitative data was done through pre and post tests. So students were either treated with, first students took a pretest and were then treated with either the simulation or the immersive virtual reality and were then given a post test. The difference in scores were then compared to each other to determine if there's a statistical significance between either of them. Yes. And so our qualitative data was really guided by Gibson's affordance theory and embodied learning cognition, which I will get into on the next slide, so you don't have to worry about that. But pretty much what these allowed us to do was to create a systematic thematic analysis, which is recommended by Braun and Clark. So pretty much how this goes is me and Akal Preet, who is one of the other authors, looked through all of these student quotes. There were thousands of student quotes, and we sat down and we looked at all of them. And then we made some kind of small themes. Maybe a couple of students were talking about there wasn't enough space in the classroom, or some students were like, I really like seeing the atoms, or some students were like, I wish there would have been a little bit more instruction here or there. We then narrowed those down even farther into even broader topics to kind of come up with our key themes that students were talking about. That being maybe barriers to entry, which encompass that, there's not enough space or there's not enough instruction to kind of make these large qualitative findings based off all of these student quotes. That allows us to kind of draw these large ideas. So our theoretical framework was guided by affordances theory and embodied cognition theory. So affordances theory, basically what it says is the actionable possibilities that the environment offers an individual based on the relationship between environmental properties and the perceiver's capabilities. Basically, what this means in simple terms is that there are certain affordances offered by the environment. The best way to describe it is through an example. So an example is a study guide can afford focused, self-paced analysis of abstract concepts. So a student is afforded, this self-paced, self-learning environment by the study guide. While in immersive virtual reality, affords this multi-sensory exploration where the students are able to hear things, they're able to see things, they're able to touch things. They're also afforded real-time feedback with these activities where they are touching things, moving things. Somebody, the narrator in their ear is telling them, oh, yes, that's correct. Oh, no, that's incorrect. And this embodied problem solving. So, why this matters, this multisensory exploration and embodied problem solving, is all because of embodied cognition theory, which states that learning is connected to the physical experiences and interactions with the environment. That being, somebody who, let's say I had a bunch of colorful blocks, and I said the red blocks are oxygen, the black blocks are carbon, and the white blocks are hydrogen. And I told a student to balance out a chemical reaction by picking up these blocks and moving them around versus a student who sits in a lecture and listens to a teacher explain how to balance that same chemical reaction. Embodied cognition theory says that the student who is manipulating those objects should be expected to develop a stronger conceptual understanding than the student who just sat there and lecture. So the simulation sits somewhere in between that, multi-sensory exploration and that kind of self-paced study guide. So investigating the immersive virtual reality versus the simulation offers us a pretty close comparison between the two, which is why we investigated them. So on to our results. So as I said, the quantitative data is still being processed, so you can follow up in a few weeks and we may have that out. But onto the qualitative data. So we developed these three themes. So the theme of interactivity was our first theme. Essentially, what interactivity stated is students found either the immersive virtual reality or the simulation to be more interactive, that being like hands-on or fun or engaging, more enjoyable overall than the other. And about 51% of students mentioned this in the first week, and then 44 in the second week. A lot of these students were referring to the immersive virtual reality over the simulation. So they're saying the immersive virtual reality was more fun, it was more engaging. They preferred doing it more. They felt as if it helped them stay focused for longer because they were actually having fun with it. For theme two, the barriers to entry, that was the accessibility. Was it easy to use? Was there good instruction with it? Was there enough room in the classroom to do it? Technical difficulties like the headsets not being charged or computers being dead or actual physical sickness with the VR headsets where students were getting headaches or eye strain or getting motion sickness because they weren't used to it. About 16% reported this in week two, 24% in week three, and 47% in week four. One important thing to mention in week four is the question was a little bit different, where students were asked what could be improved. So the big key takeaway here is that there's still a lot of room for improvement in terms of the virtual reality because a lot of these students are facing a lot of these barriers to entry, either due to poor instruction or this physical sickness aspect, especially. For visualization, students coded this at 9.1% and 13.5% for weeks two and three. A lot of this was saying like the students appreciated seeing the visuals in the VR more, being able to pick things up in 3D. Okay, on to the conclusion. So the immersive virtual reality versus the simulation provides a lot of perceived affordances for interactivity, with about half of those students recognizing that there is more interactivity with immersive virtual reality or simulation over the other one. So there is a lot there, as well as um, a lot of the visualizations suggest that IVR really had an advantage for the spatial reasoning, especially with the atomic structure, which is looking that like it may lean towards being favorable for the IVR in terms of the quantitative data. So overall, what does this mean? IVR, the immersive virtual reality, offers value in visualization and that interactivity aspect, while simulations are much more reliable and accessible for students to consistently implement. So until we have the quantitative data, we cannot make our for sure claim that one or the other is better. So make sure to stay tuned. Thank you very much for sticking around to the end if you got this far. And stay tuned for more as we have a lot more research in this area that still needs to be processed for coming semesters. So thank you very much.